Welcome back all, this is Daz from Motorola Techniques. So up this week we're looking into some more ArCoMoRa. I did a video last week on the ArCoMoRa AR-Loco interface. So this one we're looking at the Mardec, which is pretty well an all-in-one encompassing DCC stationary decoder. So the beauty of this decoder is that it is Arduino based, however Nico from ArCoMoRa has designed it in such a way that it's similar to the AR-Loco in regards to it's sort of like a yes and no sort of interface, how to set it up with a myriad of functionality, including servos and controlling LED lights. So big shout out to all my people out there that have bought me a coffee or buy me a beer. So I will put a link to that below. I'm just obviously trying to get some funds together to buy some more microphones to upscale the content and make it better and just keep it rolling. So without my contributors, this channel is really nothing. So don't forget to subscribe, like, hit that bell icon to be notified of upcoming content. So enough the waffle, let's get going. So there's a few different components we're going to need this week with this little build as well. This one we need an Arduino Uno. You can use the Nanos for these as well. I won't show you how to do that today, but it's just the same sort of functionality. If you want to use the Mardec shield, which is or the DCC power shield like I've got here, you will need the Uno because it's obviously spaced for the pins. I'll show you how to put that together shortly. So very, very easily to put together. I won't go through the components like I did with the AR-Loco last week, just purely because it's probably going to waste your time. So probably the hardest bit of the whole build here is just to make sure you get the resistor or the correct value resistor in the correct location. Other than that, it's a very, very easy build. It's got two different options to it. So you can either power, I'll just plug this in, so it's just obviously got its pins down the bottom here. It's just a matter of just lining up the pins and then snapping it together as we did last week as well. So there's two different power options. We can either power the board, the DC power shield off the Arduino itself. That's the way I've chosen to do it. You can choose otherwise. So you've also got another, you can power it off here. So it will power not only the board, but the Arduino as well. Just a few extra components that need to go in that all come with the kit, and the instructions show you how to do it. Just be mindful, you can't do both. It's either one or the other, else you'll blow this little guy up. So let's get into having a bit of play with it and some of the experimenting I've done. While we're talking all things PCBs and the like, I'll have a quick message from my sponsor. Over to you, PCBWay. This video is proudly sponsored by PCBWay.com. If you're a tinkerer, inventor, or advanced electrical engineer, you need to check out PCBWay or you are seriously missing out. They are passionate about PCBs ranging from standard to advanced PCBs with 1 to 30 layers with full-featured printed circuit boards. PCBWay don't stop there. They offer basically everything you need to make your ideas a reality. Whether you need 3D prints, injection molding, or CNC machining, assembly, or basic PCB manufacturing, they can do it all for highly competitive prices. Check out their awesome services in the link below and their offer to my viewers who support this channel. Watch out for my upcoming videos where I'll be using some of their products. Right, so what we're going to look at doing here, as we did with the AR-Loco, is we use the upload tool. I'm not going to go through and download all the programs again. I'll put a link below to the video last week. I'll show you how to do that. So we're going to the upload tool now, and it's asking, is the Arduino or Next DCC connected to a USB port? Which, yes, we are. Then it's going to ask you what COM port you're with. So if you don't have anything here, it says USB serial or something similar, it probably means you're going to have to go and hunt down where your USB is plugged in or whether you have the correct drivers for it. So I'm not going to go into all that side of things. There's plenty of lovely videos out there. So this one is just a matter of typing in COM port 12 or COM12, I should say. And that's going to ask us what sort of device we're going to use. So we're going to go Uno again, but this, what I'm doing here, so you can use a nano. There's not as many output pins. That's the only thing. And press OK. And then we want to know which program we want to use. So for this one, we're going to go the Mardec, which is the stationary DCC decoder. And then we're going to go upload Mardec to Arduino Uno on port 12. And that is a yes. And then you're going to get this command prompt screen, just as we did with the ArLoco, so it's exactly the same. And if you get Mardec is successfully installed on your Arduino or your DCC Next, we're good to go. Would you like to create a shortcut? Yes, we will. What I'll do, I was going to go Mardec 1. So that'll become apparent just as I did with the ArLoco. I number my modules so I know that module 1 is in a given location with specific DCC addresses, so I don't get it mixed up, and I'll actually note that down on our spreadsheet that I've got. So Mardec 1. Alright, so just as with the ArLoco, we've got this one, but it's obviously the Mardec, which is multifunctional Arduino DCC decoder. So that's a fancy way of saying it's a stationary DCC decoder. There's many different things, and we'll just touch on a few of those, what you can do today. So we'll just do a very quick setup of it. So enter the value. So this is the administrative number that I was talking about before that represents the sticker that I've got on mine. So module number 1. All right, so do you use a Roco multi-mouse or Z21? So this is a very interesting one because for some reason Roco have a 4 address offset. So what I mean by that is if you've got 1, you need to program in 5. So I use a Z21. However, I turn that function off because it just gets all too confusing. So for all intents and purposes, I'll be saying no because I don't need the offset. Now, default rotation speed is for the servo. So 25, we can always go back in and change that. Detached servo at the end, yes, so we don't get the chattering as they're picking up a signal. So the setup mode. So this is an interesting one. So what this means is, so when we turn it on, it's either going to have, so when we boot this up again, the Mardec interface, it's either going to have the last definition configuration or normal. So I'll normally just go whatever the last one was. So now we can see that we've got ports over here, 1 to 16. So that's the amount of ports or different 16 addresses that we can use. So just let me adjust that, and right down the bottom here, you can see what command. So enter command, and if you're new to this, like sort of I am, there's a question mark at the end. You go question mark and it tells you what P means, which is select port number. A, port address. D, display all. E, exit normal mode. Set up basic information or reset. So if you want to do a reset, that totally wipes your Mardec. So we're going to go port, and on this one I'm going to look at port number 9, and I'll show you the reason why that in a sec when I show you a little rig that I've set up. So set DCC address for port number 9. So I'm going to go for a range from 13 on 1 to 28. So that's my 16 DCC addresses. So for port number 1, I'm going to go address 21. Now, So this is where we either select what the port is for, so the type of port. So it's either an accessory, so to turn something off, input, which is inputting something, so like a button or something on your fascia, or to servo. So at this point in time, we're doing A for accessory. And now select mode for the accessory. So this is where we select all our light type functions. So there's a 0 for help, so we'll do that. And it gives you 9 options, from single steady, double steady, flashing, flickering, all the way through. So we're just going to go a single steady, which is basically a single steady is 1 command for on, 1 command for off. So number 1. And then with that, we have another lot of commands. So you can go the question mark, so we can either test the port, modify mode, invert the port, the DCs or display, or we can put a note on it. Enter and save port and start normal mode. So I'm going to go for E because that's save port and start normal mode. So normal mode is like when you want to actually use it. So you just got to remember to do that, because if you leave it in the mode, the configuration mode, and you go back out of it, just like the ArLoco, it won't work. So you just got to make sure you push E, or you can go P, but you're saving that individual port, so port number 9 that I'm doing here, and then you go into another one, so you program another port. So we're just going to go and have a play. I'll just go through the little rig that I got set up here. So I'm powering it up at this point in time just for the ease of the programming side of things with the USB. Normally, so out in the layout room, the way I've set it up, you'll be powering it with a 5 to 12 volt power supply here. Over here on the far right hand side is just a little light rig that I made up with 8 LEDs on it. So currently we've got the common here, this blue wire at the top here, and the very first LED on the very bottom of the screen here, with this green wire to pin number or port number 9, as we've already justified. So what we'll do, we'll quickly go over to the interface, and I'll show you what it actually does. So we're over at the interface here. You can see this is the DR5000 interface. So let me quickly turn that on. So that's now turned the power on. So I'll just quickly go back over to the power shield. You'll see the very top light here. The green light is DCC available. So I'll turn that off and I'll turn it back on. So you'll see the DCC come up there. So then the light just below that is the power button. So that means this board is now powered up, obviously, with the feed from the USB. Then you'll see a little status LED, so that'll flash when you're actually using one of the functions. So that'll go red. So back over to the interface here. So in the middle here, this grey one, we've got the Mardec. So you'll see accessory address number 21 on port number 9 is turned off. So as I said, I need to probably go in and invert that, just so the LED is off when port is off. So then you'll see the Digikai's DR5000 switchboard. So a switchboard interface here, and you'll see down here is address number 21 is what we've addressed this pin to, or the port to. So you'll see back over to the interface now, and there's a few things going on whilst we're doing that. So I've now just quickly gone back in and inverted it. So accessory number 21, sorry, port, so pin number 9 is currently turned on, LED is on. So we'll go and send an off switch command, and you'll see the status light go, and then the LED is now off, and you can see that the LED is, the pin number 9 is turned off there. So we're back in the configuration screen here. Now, what I'm going to do is, next light we're going to do is sort of like a flickering light. It's either like a gas light, which looks quite nice if you're modeling sort of vintage era gas lanterns. So we'll go into P for port. Let me drag that screen up a little bit further. P for port. So we're going on port number 9. And now I've had a bit of a play around with this, so I'm just going to go, we're going to go to modify. So we're going to go into number 8, which is the flickering light. Now the first value it's going to want, you need to have a play around with this because some of them are quite subtle, between 10 and 255. So it's a PWM, so pulse width modulation value. And then I'm going to go to the extreme 255, set the maximum PMW value for the port. And then with that, just make sure we go back to our question mark if you're not sure. So you've got to save, port, and start normal mode. So as I said, normal mode. You must get out of normal mode, as this thing just won't work. I've been caught out a few times like that. So E. All right, so now we're good to go. So what I'm going to quickly do is bring that to one side. Let's turn our DCC on. Get that out of the way. You'll see, obviously, we're still on address number 21. And so I need to probably invert this one because it's going to start, as soon as you turn it on, it's going to start flickering. So as you can see, it's now stopped flickering, I should say. And now we're flickering again. As I said, that's quite a harsh flicker, probably more of a campfire or a welder or something similar. But if you just want that nice little gas light flicker, you can play around with these values. All right, so the last thing we're going to look at here is to run a servo motor. So this is by no stretch of the imagination going to be a deep dive into it. So I've only just really started playing around this myself. So comment below if it's something that you would be interested in where I can do a deep dive in, because there's quite a lot of functionality regarding the servo motor. So up on the screen here is the way I am wiring it up. So you'll see that this is actually the DCC Next version. However, the principle is exactly the same. So if you've got the DCC Next, you use your DuPont plugs straight into 1, 2, 3, 4, but it only allows you to do 4 servo motors. So with this way that I'm doing it, a little more work, but it allows you to do a whole lot more if you wish. So here's the so I'm just using the 9-gram servo motors. You do get what you pay for with these, so always spend a little bit more money, and they last a lot nicer and they're less noisy. So you'll see in here on port number 7, we won't be using on port number 7, but just for this diagram is the control line, and then you've got the positive and the negative feeds off from the servo as well. So where I made a mistake is you just got to be mindful, you have to have this negative here on your whatever you're using, whether you're using the power shield like I am or the next DCC Next. You will need to make sure that you've got this common ground here, else it just won't work properly. So let's go over to the interface. All right, so what we've got here, we've got a few things going on here. I've got the DCC power on from my Digikai DR5000. I've got the switchboard here for the turnout addresses to switch the solenoid. So I'll show you how it's actually what we're trying to achieve here, and then I'll work back and I'll go through some of the settings, how to get to this basic, just have a bit of a play around with it. So obviously we've got the Mardec number 1 interface on COM port 12 as we set up before. And inset, it should be a video of the solenoid working. So I've just put a little broken down popsicle stick. This is by no means meant to be scale of anything. It's just so it's easier to see the movement going up and down. So I've put this in on address number 13 for the solenoid. So still on 21 is my flickering light. So let's just give that a bit of a flicker. Yeah, that's still working beautifully. We'll turn that off. So you'll see up here is the solenoid. Obviously the wiring, as I explained on the wiring diagram before, and obviously a very crude way of wiring it, but that's just for bench testing purposes. So I'll now go and you'll see the boom go up. And what I've actually set is a little bounce, so you can actually set that in there, and then the boom going back down. So it's just a matter of working out the angles and all that, which I'm still yet to play around with a lot of, and how you would integrate this into, you know, either to turn for your turnouts or your points, a boom gate, or I'm looking actually doing a funicular, what they call it in Germany, a miniature wonderland is, so watch that coming up in the future where it'll be spinning a sine. So then we can bring it back down, bring it up. Then obviously on the screen here, you can see highlighted here in yellow, if your Mardec is still connected to the computer, it's giving you some degrees, so 76 and 105. So as I said, I'm still learning what this all means and how that actually integrates and how you measure the degrees on the setup here. All right, so I'll show you just very, very briefly how to set it up so you can just start having a bit of a play with it. So we're in on for the servo motor, in on port number 1, DCC address number 13, as we showed before with the switch command. And we've obviously selected a servo, not inverted, and the angles. So as I said, the angles are something you need to play with, and also the speed, which is a very interesting one. So you can obviously have it a lot quicker. So this is sort of about half speed. And frog polarity, I won't go into that. And obviously the bounce is what I was playing with before. So same as before. So you'll see down the bottom here a whole lot of commands. So in what command? So if you're not sure, you go and you work out. So we'll select port. We'll go port number 1. And now you can see, because I'll drag that up a little bit, because I've selected this as a servo, when you go and, so when you initially go and define this port number 1, it gives you a lot more detail in what you can do. So I will show you that. All right, so as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 different variables here. Well, not variables, but different functions we can do. So we've got raise, angle, lower angle. So that's obviously when we're starting to fine tune. So if there's anyone out there that is more au fait with this, I'd be very interested to know, when you've got the servo installed, you're not going to know the exact angle of every one. So how do you go on the live layout to fine tune either your signal or particularly your switch? Probably not so as important for, say, a semaphore signal or a boom gate, I wouldn't think, but definitely for your switch or your point, how are people doing that? So from there, what we might look at quickly is, we'll go into the bounce. So the bounce angle is going to give you a value from 0 to 9,999. So that's obviously an angle that it's after, so the low angle. So okay, so on the bounce command side of things, what I think it's quite clever how this works. So it's you put in a 4-digit code. So as I said, up to 9,999. So let's give an example of what they've got here in the user manual of 531. So the first bounce goes 7 degrees, then it goes back to its start position. The next number is obviously a 5, so it goes 5 degrees back to its start position, and then 3 degrees. So there's 3 different aspects to the bounce between 7 and 3 degrees. And then finally the servo goes back to the 1 degree position. So that's obviously quite clever. So if you sort of have a play around with how much you want that to bounce, between, as I said, between 7 and 5 degrees. So I had mine initially, I think I had mine around 550, 500. So what we'll do, I'll just show you that bounce with the example that Nico's given here. So you set the value for the high, and then also let's do exactly the same, see what that looks like. As I said, it's just a matter of trial and error, how much you want it to bounce. So we'll go E, so we go back out to our Mardec interface. Quickly bring over the switch commands, and then we'll have a look at what the bounce looks like. So I'll go down first. So that's the arm going down. Okay, so what it's actually done, I've set the bounce on the lower end of the scale now as well, and then the upper end. So the lower one I've just set, so you can sort of see that's much more subtle up and down compared to what I did on the first one. So let's go back to C, which brings up our interface. P for what port we want to go to. We're on port 1, so we can get back to our servo port. And let's see what else we can have a look at doing. So we've done the bouncing. The other one you might want to have a look at is setting the speed. So let's go and have a look at speed. So we've set that you can set it between 5 and 100. So I've set it at 50. So let's go the upper end and just see how quick that looks. So I've set it on 100. Let's go E for saving that and bringing us out to allow us to function. So let's bring our port back over. All right, so the higher the number, the slower it is. So let's just go and have another play with that, and let's go. I'll just quickly race around here for the interest in keeping this video a little bit shorter. So what do we want? We wanted S for speed. Let's go 5. So 5 should be as fast as it goes. All right, so you can see 5. You'd never use that. That's very unrealistic unless it's some sort of animation you're looking at doing, but 5 is obviously very, very fast. So as I said, I first had it on 50. So I think that's probably around the mark, or you could probably go maybe 60. All right, so that's a bit of fun. So what else can we have a look at doing? Okay, so the function we're in here is the relay function. So I won't dive too much into that, but effectively what you can do, I'll just move that out of the way, is use an Arduino type, what I call an Arduino type relay that can be controlled by the 5-volt here via the optiocoupler, and control the polarity to your point, to your frogs and the like. So that's just a matter of, it's going to ask you how many relays. So this particular example, it's 2 relays, 2-channel relay. So let's just see what it does. Let's just go down. Obviously now what it's going to ask for is what port you want us to connect it to. So if you want to control, say, a servo and a relay, or 2 relays like you're doing here, it's effectively 3 ports. Will be 3 ports, 1 for each of the relays and 1 for the servo. And let's just go 2 just to make sure we do it, and then I'll ask you for the second one, so I'll go 1, 2, 3. It's up to you how you'd want to do something like that. So let's we'll go back to test. It's going to allow us to test, and then always remember E, which obviously saves it saves everything to the Mardec, and to the Mardec Arduino, and then it allows you to actually control the servo or the function you're trying to control. Just a very quick video on the functionality of the Mardec with ArCoMoRa from Nico from ArCoMoRa. The servos have got me really interested. So I'll probably do a lot more with them into the near future. As I said, there's other modelers out there that have got probably a lot more experience than what I've got. As I said, I'd be really interested in how you fine-tune the servo once the servo is installed and you might be away from your computer. I'm very interested to see how that might occur. So thanks for watching again. Don't forget to subscribe. Click that little bell icon to be notified of upcoming content, and I will see you next time.